So we're going to start having a look at the feedback for the distance, speed, time checkup 2 that you did on Monday. But to begin with, we are going to do a bit of a recap on what you should know for this topic and bring everything together. Then we'll look at each of the questions that you were faced with in the checkup. So, very beginning of this topic, we had a look at how we work with decimal time. Time and decimals don't work very easily together because decimal systems based on lots of tens, hundreds, thousands, whereas the time system with between seconds, minutes, hours, it's all about 60 seconds in a minute, 60 minutes in an hour. Then it gets different after that, 24 hours in a day, and so on. So not easy to work with, so we need a few rules to help us with that. So some standard results that you should be aware of. 15 minutes is the same thing, I'm sure, as you know. A quarter of an hour is another way of saying that, and a quarter as a decimal is 0.25 hours. 30 minutes, the most obvious one. Half an hour, again, half as a decimal is 0.5, and 45 minutes is 3/4 of an hour, and 3/4 as a decimal is written as 0.75 hours. So these are equivalencies, so 15 minutes can be written in hours as 0.25 hours, and so on. In general, however, you're dealing with, when you're changing or writing minutes in terms of hours, you need to think about it as being a fraction of an hour. So 24 minutes is 24 divided by 60, it's 24/60ths of an hour. And actually, for any number of minutes, we can change them into a decimal hour in this way by dividing by 60. If you want to reverse that, so if you do a calculation and you get an answer that is a decimal, and you're a decimal number of hours, and you're trying to interpret it back into minutes, then you do the reverse of dividing by 60 and you times by 60. So this little diagram here with the minutes and the decimal hours changing from minutes into decimal hours, the process is divide by 60. If you're going back the way, you're multiplying by 60. But these ones on the left here, these are ones that you should just try to remember. 15 minutes, quarter of an hour, 0.25. 30 minutes, half an hour, 0.5, and so on. Of course, if you put them together with hours, so if you've got something like 2 hours and 15 minutes as your time, it'd be written as 2.25 hours. And you can see that down here with other examples. So 2 hours and 24 minutes, for example, you'd convert the 24 minutes into decimal time by doing 24 divided by 60. As you've just seen at the top there, that gives you 2.4. If you're reversing it and you get a decimal answer, it's the decimal part. So here, 5.8 hours, the 0.8 bit, you would times by 60, and that would give you your 48 minutes. So make sure you know how to work with decimal time. The formulae for doing all these calculations, distance, speed, time that we would be looking for. So if you want to learn this little triangle, it can help you get each of the formulae. The way you use it is if you wanted to, if you're asked to work out a distance, if you cover up the D, you'll see the S and the T are on the bottom side by side. That tells us that our formula for working out the distance is going to be distance will be equal to, and we'll use the S and the T, and they're, because they're side by side, they are being multiplied. If you wanted to calculate the speed, on the other hand, if you cover up the S, you'll see that the distance is above the T. So working out your formula for speed, you will have speed equals, and you would have distance, and it's divided by time. And the last one, if you cover up the time, you'll see you've got the D at the top, So you'd have your formula for time would be equal to your distance. Then you've got your line, which means divided by, and you'd have, not the time, you'd have distance divided by speed. Okay, so that's your three formulae. I would learn that if you learn the triangle, know that they come alphabetical order, so that D is always up at the top of your wee triangle, and you can easily produce any one of those three. Now, when you're using them, it is quite important that you understand the units that you're using and how they need to match up. So distance is always measured in things like miles, meters, kilometres, it might even be centimetres if we were talking about distance that a snail might travel or whatever. So it can be short distances as well, but those are distance units. Time units you should recognise can be things like seconds, minutes, hours, days, months even, years, right? They're all lengths of time. The speed units that we need you to think about are, because the formula for speed is distance divided by time, which can be written like that or like this second line here. The distance units, remember, those are things like miles, meters, kilometres. The divided by bit is the bit that when we're using these units, we use the word per in it, and that means divided by, and then whatever the time units are. So if your distance is measured in meters and your time is in seconds, your speed units will be meters per second, which you can either write out in words or you can write like this with the little meters / the S for seconds. Other common ones are miles per hour, might be kilometres per hour. Again, it just depends on what distance units. So distance units per time units based on what you put into the formula. There can be other ones there, so centimetres per minute, miles per day, and so on. So make sure you're aware of all those different questions. So on to the feedback the speed, distance, time checkup 2 that you did the other day there. So this first question, a car travels for 275 kilometres. So the information, that 275 kilometres you've been given, that's telling you a distance. So they're telling you 275 kilometres, that's your distance, at an average speed. So they're telling you the speed is 56 kilometres per hour. And how would you work out how long? So how long, that's talking about working out a time. So if you cover up the time and the formula and the table, you will see that you should then be doing distance over speed. That means distance divided by speed. So you would be looking for that to be 275 divided by 56. Okay, just realised I've written that the wrong way around. Right, so 275 was our distance. So 275 kilometres divided by the speed. So the answer that we should be looking for there was answer B. For question 2. Which of the following is not a measure of speed? And we've just talked about that, the units. Right, the formula for working out the speed, if you cover up the S, you'll see the formula for working out speed was distance divided by time. Distance over time. Or we can write it that way around, distance divided by time. So that means we're looking for a distance unit divided by a time unit. So millimetres, that's distance per hour, so that one's okay. Miles per metre, that's miles is a distance unit, metres is a distance unit. So it's this one here that is clearly wrong, and you can check the other ones. Kilometres, distance unit per time, metres per second, right, again for D. So those ones are correct, but the answer which was wrong, right, was answer B. Miles per metre is not a measure of speed. Right, speed needs to be distance unit per time unit. For number 3, Stephen cycles a distance of 24 kilometres. So distance is 24 kilometres in an hour and a half. So that's a time unit you've been given, so 1.5 hours. Calculate the average speed in kilometres per hour. So again, if you're wanting to work out the speed, cover up. You can see the formula for speed is distance divided by time. So your distance unit would be 24 kilometres divided by your hours. Now 1.5, right, that's one of the ones that the half an hour, the 30 minutes, we expect you to know goes in as 1.5 when you do that calculation. So once you do 24 divided by 1.5 on the calculator, your answer would come out as 16, and that would be kilometres divided by hours, so kilometres per hour. So your answer for that one should have been answer C. For question 4, a plane flew from Frankfurt to Hong Kong. Flight time was 10 hours 45 minutes. So writing down for yourself the information like this and then thinking about what is it I'm trying to work is a good idea. We know we're going to have to change that 45 minutes. That's again one of the standard ones. It becomes 10.75 hours. The average speed was 852 kilometres per hour. So that's why we need that 10 hours 45 minutes to be written in terms of just hours. So we're looking to work out the distance, right? So what is the distance? So if you cover up the little d, you'll see that's the formula where the s and the t are on the same line. So that means your formula for distance is where you're multiplying them. So speed times time. So you should have been doing 852 times by the 10.75, and that would have given you an answer of 9,159, and that would be kilometres. So it was answer A that we were looking for. And for the last question, right, in this one, Anwen walks at an average speed of 3 kilometres per hour for 2 hours. So that would be our speed that we're given first of all. So the speed is 3 kilometres per hour. The time that you've been given is 2 hours and 20 minutes. That 20 minutes needs to be converted to decimals, so we need to do 20, and remember that to change it into decimal you're going to divide by 60, 20/60ths of an hour, and when we do that it's going to come up on your calculator with a little dot. It'll come up as 0.3 with a dot above the 3 possibly, and actually if you press the SD button again it will show you that actually what this is doing is it goes on and on like this. So I would suggest using just 2 decimal places for this, 0.33 hours, and then putting that together with a 2 so we can write this as 2.33 hours. So it's these two numbers here that we're going to use. We're working out how far, remember, so the how far one was working out the distance formula, and the distance formula, as we've just seen a minute ago, was speed times time. So we are doing 3 times 2.33, and that would give us a distance of 6.99 kilometres. Now when we check through there's none that's exactly that. Why is that? Because this, we rounded at this bit here, so the closest one to the nearest whole number would be that one there, which would be answer D. So hopefully going over that has helped. If you could look at your own solutions, check all your work in, and make sure you take on board anything that you need to improve on.